All right, this is our only video on stem and leaf plots. We spent a lot of time on dot plots and line plots in the last few weeks, and we want to understand that stem and leaf plots are another way to organize data. And I'm going to give you an example. Here's some raw data that we had used earlier, some made-up ages of teachers at Hamilton Middle School. Sorry, I missed the bottom of the G there. All right, made up data of ages of teachers at Hamilton Middle School. And so this raw data, it's not ordered, it's not organized. So we've learned that one way to order data quickly is to make a dot plot. But the problem is with this dot plot, this data is so spread out. That wasn't an efficient process at all because I ended up having to make that straight line with all those tick marks. But that data was so spread out that only one number was repeated, and it really wasn't a great way to organize the data. So today we're going to learn about stem and leaf plots, which are a good way of organizing data quickly in a graph that's easy to read, and also will be easy to create. So a stem and leaf plot, I'm going to zoom in for you real quick on that. So a stem and leaf plot, I'm going to zoom in even more. It uses the digits of each data values, to organize a data set. Each data value is broken into a stem, which is the digit or the digits on the left, and a leaf, which is the digit or digits on the right. A stem and leaf plot shows how data are distributed. So this data right here is actually showing 20, 20, 21, 22, 25, 27, 31, 34, 38, 42, 58, 59. See, because the stem is showing the tens place, and the leaves are all answers in the ones place. And so by organizing it this way, you save yourself the time of repeating all the numbers that start with a 2. Obviously, there's no data below 20 because that's the first item in our stem and leaf plot. So this is just an introduction, but I'm going to go ahead and show you that same teacher data here. And you'll notice that when I have this data in my stem and leaf plot, it makes it very easy to see how the data is spread out. You will notice that when using a stem and leaf plot, there's no need to put commas in between the digits in your leaves, and that's because the leaves will always be a single digit number. So it saves you the aggravation of a comma, confusing them with decimal points, etc. And so this data in order is 24, 25, 28, 28, 32, 34, 38, 41, 44, 48, 52, 62. Now, when we look at this, a couple of things can happen. If I asked you the mode of this data, somebody say the mode is 8, but trust me, there's no 8-year-old teachers at Hamilton Middle School. The most common answer was 28 because it appeared twice. So that's one thing you certainly have to be careful of when you're reading a stem and leaf plot. Now, what's similar here is this dot plot also allowed me to read those numbers in order. So that's great. I can use that. Sorry about that. I can still 24, 25, 28, 28, 32, 34, 38, 41, 44, and so on. I can still do it. But the stem and leaf plot allows me to do it in a much faster way. So I guess it was a week ago, over the weekend, I put this question out here, is that I've got a big cousin problem. And so I actually created an extra credit opportunity over the weekend. Only about 15 or so students took advantage because they probably just didn't look for work on the weekend. So maybe those students have notifications enabled and were aware of it and checked it out. 2 simple questions I asked them. I asked them to take a guess at what they think the big cousin problem was. And then also I asked them to make up a name and a number from 5 to 58. So I wanted to just share with you some of the guesses that we had. Some people, I think Mr. G's cousin is big. They're having trouble cooking. I think Mr. G's cousin is better at basketball. Well, that's probably possible. Mr. G's cousin is bad at math. I think Mr. G misses his cousin because of coronavirus. That's an excellent guess. Mr. G's cousin is really tall. No, that's not it. I think Mr. G's cousin's angry with him. Oh, I'm glad they say that that's not my big cousin problem. I think Mr. Gallagher's cousin can't visit him. I think Mr. G's cousin is angry with him because math is very difficult for her. I think Mr. G doesn't get along with his cousin. His cousin can't come to his house. I think Mr. G's cousin is coming to town. I don't see why that would be a problem. I think Mr. Gallagher's cousin is too stubborn. I think it means just a jokingly way to say I have a big problem. I like that answer a lot. I think Mr. G isn't friends with his cousin. Ugh, that would be a big cousin problem. I think he has too many cousins. So those were all good answers. Unfortunately for you guys, they were not correct. Mr. G's big cousin problem is he has no cousins. Yeah, it's true. Even though many of you might have cousins in the dozens, Mr. Gallagher does not have any first cousins. So you know that a first cousin is when your mom or your dad has a sibling, and then that sibling has kids. So if your aunts or uncles have children of their own, they're your cousins. And cousins are great. They're like your first friends, and they're great relationships. Unfortunately, even though my mom and my dad both had brothers or sisters, none of them had children. So I don't have any cousins. So the data that I collected when I asked people to give me a name and a number is so that you can solve my big cousin problem by being my cousins. So you guys helped me make up about a dozen or so cousins. So here were the cousins that people came up with. Scott is 14, Deanna's 22, Deara, Blake's 44, Ryan's 33. What I'm going to do is I'm going to show you how to make a stem and leaf plot using the data that I just collected. So we'll go ahead and we're going to put the data in as we go. And that's the whole purpose of a stem and leaf plot, is to be able to collect data as you go. So Ryan is 33. I will place a 3 in the leaf where the 3 stem is, and that makes 33. Blake is 44. Deara is 22. Scott is 14. Now the reason I started with 0 and ended with 6 is I did tell everyone to make sure that they kept the ages between 5 and 58. And so I'm understanding that if there was a 5-year-old, I could put them there, a 58-year-old go there. I don't really need the 6 there, actually. Okay, so Scott was 14. Gianna was 24. Now you'll notice that the 4 goes right there after the 2 with no comma. Mia is 28. Rachel is 38. Allison is 44. I guess you'd say that as Degia or Dejaya? I'm not sure. I've never heard that name before. So it's a 23. Tony is 13. Tim is 51. Noah is 48. Darlin is 34. Angel is 21. And Lewis is 39. And our last example of Sarah is 41. And you can see that the age group where the data clustered the most was in the 20s with 5 different cousins. And you'll note that this data is not in order. And that's why I have 2 stem and leaf plot setups here, is because what I want to do now is I want to rewrite that data in order from least to greatest within each stem. So there's no data in the 0 stem, but there's both a 3 and a 4 here. Here we've got a 1, a 2, a 3, a 4, and an 8. In the 3 stem, 3, 4, 8, 9. In the 4 stem, 1, 4, 4, 8. And the 5 stem's got a 1. And what I can do now that I've got my stem and leaf plot in order, I now have all my data in order. I can read you the ages of my new cousins in order from least to greatest. 13, 14, 21, 22, 23, 24, 28, 33, 34, 38, 39, 41, 44, 44, 48, 51. And the cool thing here is I did hear myself repeat the number 44. Instantly I know the mode of my data. So you can see that this is a much more efficient way of organizing data when it's a little more spread out. You know, a dot plot is great when your numbers are within, like, let's say 10 or 12 numbers of each other. When they're really spreading out and it's not a lot of data, you're better off using a stem and leaf plot to organize your data by place value. So we're going to look at a couple of stem and leaf plots. I'll go ahead and zoom this back in. And so here's data on how many books people read. Okay, maybe it's how many books they read in a year. Maybe it's a month. I don't know how good a reader they are. But you're going to see that using this stem and leaf plot, again, I started with 0, but I did have a single-digit answer, and that's why that went there. Notice that in each leaf, the numbers are in order from least to greatest, and that's important. This 0 doesn't mean that there are no people in the 40s, it means that there was an actual answer of 40. So I bring you to this example, which is, I guess, really important because two special things are going on with this example. One, I didn't start with 0 because my lowest number was 62. So when I make my stem and leaf plot, I'm going to start with the lowest stem I need and end with the highest stem I need. But even though there were no answers in the 70s, I still included a 7 here. And I didn't put a 0 because that would indicate that there was a 70 in my data set, which, as you can see, there was not. But again, my data is in order, and it's going to show me that gap. If I had not included that 7, I wouldn't have known there was a gap in the 70s in this data. It wouldn't have been obvious. Another interesting stem and leaf plot is this one here. You'll notice that you can use decimal numbers and plot them in a stem and leaf plot. But notice that my stem changed. It had a decimal in it. 1 and 6/10, 1 and 9/10, 2 and 0/10, 2 and 2/10, 2 and 6/10. So you can see that a stem and leaf plot can order items even with decimals. And then here's another fun example. This, I don't know how fun it is, but this example you can see is showing me that my data is actually 3-digit numbers. But those 3-digit numbers are fairly clustered in that they're all between 200 and 259. And so what I can do is I can show 201, 203, 204, 205, 206, 208, 208, 208, 210, 217, 218, 218, 219, and so on. So a stem and leaf plot can be really helpful in, again, organizing data quickly. We're going to go ahead and try this a second time where we're going to take some data, we're going to plot it just so you can see how the plot works. Some people make the mistake of just trying to find all the 4s and put them in order to save time. I understand why, but I assure you this way you can be sure you get every single number. So I'm going to go ahead and plot 45, 73, 91, 88, 73, 55, 71, 83, 93, 77, 51, 65, 86, 81, and 92. You'll notice I wasn't too concerned about neatness when I did that first one because it's really just my rough draft of my stem and leaf plot. Now I'm going to move over here and this will be my final draft, and I'll make this one a little bit neater. 45, 51, 55, 65, 71, 73, 73, 77, 81, 83, 86, 88, 92, 93, 99. And so now that data is in order for my stem and leaf plot. Makes it real easy to spot my mode is 73. Again, it wasn't 3 because there are 4 3s. It's 73 because this means 83, this means 93. All right, very good. So you can also answer questions about stem and leaf plots. For example, this stem and leaf plot shows the number of digs for the top 15 players at a volleyball tournament. How many players had more than 60 digs? So you can see this data is all students who had more than 60, 62, 63, 63, 67, 75, and 97. So the correct answer would be 6. 6 players had more than 60 digs. Because the great thing is the stem and leaf plot does show you the raw data in graph form. You can see the data clearly clusters up here. That's where the data clusters. But, we can collect that raw data. So a stem and leaf plot and dot plot both order data as you collect it. So I ask you this question: which data set would be better suited for each type of plot? And this is pretty obvious. You'd want to do a dot plot here because you can see the range of the data is small. The highest number is 9, the lowest is 1. The range is only 8. So you'd want to use a dot plot because that data is very clustered. Whereas in this example, our lowest value is 14 and our highest value looks like is 76. So with a range of 62, that is much more spread out. We definitely would want to use a stem and leaf plot there. Finally, when you look at a stem and leaf plot, we can answer questions about it. What is the least value? Well, it would be 0. What is the greatest value? 35. How many values are in the set? Now, you wouldn't count the stems because they're just repeated numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 numbers in the set. What is the range? Well, we subtract our greatest value and our least value. 35 minus 0 is 35. What is the median? Now wait a minute. If there's 15 numbers in the set, that means the 8th number will be my median. So 1, 2, 3, 4, 5, 6, 7, 8. There's my 8th number. Just in case, I'll count backwards too. 1, 2, 3, 4, 5, 6, 7, 8. So the median's not 7 though. It's 17. Is 34 in the set? Let me check. Nope. And which value occurs the most? And so some people might say, oh, well, there's 3 5s, but that doesn't matter because this is a 5, this is a 15, this is a 35. The number that appeared the most was those 4s, which means 24 occurred the most. All right, that's the end of our video for stem and leaf plots. Thanks for sticking around till the end.